Welcome to this lecture. In the last lecture, we were doing some practice. Initially, we discussed about how to do the domain analysis, and then we took some examples and we tried to develop the domain model. We took the example of a tic-tac-toe computer game, and we identified the entity classes there, and that was our initial domain model. And then we had a refined domain model where we added the boundary and the controller classes. Now, let us proceed from there. So, this in the last class we had identified the board class from a noun analysis. We did not really get down to do noun analysis, but mentally we rejected all those nouns which cannot be entity classes. But as we get more experienced, we do not even have to do that. We just read through the problem and we can identify what are the entity classes. And once we identify the entity classes, that forms our initial domain model. The boundary and the controller classes are easily identified almost mechanically from the use case diagram, and then we add them here, and that forms our refined domain model. And from here, the next step would be to identify the sequence diagram. We know that we have to develop one sequence diagram for every use case, and for this problem of tic-tac-toe, we have only one use case, that is play move, and therefore, we need to develop only one sequence diagram. In the sequence diagram, when the user starts a play, how do these classes interact and finally produce the result? We display that graphically in the sequence diagram. And for the tic-tac-toe problem, to develop the sequence diagram, we need to understand the business logic well, read the problem many times and understand what really happens, and then we can draw the sequence diagram easily. Let us see here. As the user makes a move, that is detected on the play move boundary. So, these are the three classes which interact to realize the play move. Once the move is initiated by the user, that is conveyed to the controller. The controller is the one which actually coordinates all other objects. The boundary is only for getting the data and reporting it to the controller, or taking data from the controller and displaying to the user. So, the accept move, as the move is made, that is conveyed to the controller. The controller knows what to do, knows that whether need to check the validity, whether the user has marked on a square which was already occupied, or was it an ambiguous move if it is given graphically, and it checks the move validity. But how will it check? It needs to check through what are the current marked squares on the board, and that data is there with the board. So, it requests the board to check the validity. If the board conveys invalid move, then it displays invalid move and prompts to give a new move, and the use case would end here. But if it is a valid move, then it is registered on the board, and the controller knows that once the move is valid, needs to check if there is a winner, and therefore, it invokes the check winner on the board. If there is a result, either the game is over or there is a winner, that is game is drawn or the game is there is a winner, it will be announced. But the controller again knows that if there is no winner or game is not drawn, the computer has to play the next move, and it requires the board to make the next move, because board class knows all the squares which are marked and which are available, and this is the best class that can play the move, requires the play move, and then once it has made the move, it again checks for winner. If there is a result, announce result, otherwise it gets the board position and displays the board position, and if the game is not over, prompts for the next move. So, as we can see that the controller actually implements the business logic, it coordinates the actions of other objects and then realizes the use case. But seen that the sequence diagram can become complex. In our previous example, we had only 3 classes, but then the message exchanges, there are many message exchanges, but imagine if we have a dozen classes and there are large number of message exchanges among them, it becomes very difficult for a person to keep these in mind and draw the sequence diagram, and for that the CRC card has been developed. The CRC card stands for Class Responsibility Collaborator Card. It is used to assign responsibilities to classes, that is, responsibilities are actually the methods of the classes, that is, which class should have which method. The CRC card simplifies the development of sequence diagram, because here by using the CRC card we can easily identify which class would have which responsibility, and then we can develop the sequence diagram. CRC card stands for Class Responsibility Collaborator. It was pioneered, developed by Cunningham at Kent Beck, and these cards are like playing cards, small cards, maybe 4 inch by 6 inch, and here at the top of the card the class name is written, and then there is a small table here. So, the classes are already identified during domain analysis, the entity classes, boundary classes and controller classes. For every class identified during domain analysis, a small card like this is made, the name of the class is written here, and then on these rows we write the responsibility and collaborator. The class responsibility is that what exactly it should do during a use case execution, and then it can take help of which class, what responsibility it will perform, and for performing this responsibility it will take help from which class. So, that is a collaborator. So, the class responsibility collaborator diagram, if we develop for every use case, then we will have the responsibility here filled, but we do it for one use case by another, and then we draw the corresponding sequence diagram. If we think of it, the CRC cards help us systematize the development of the sequence diagram for complex problems. For simple problems, just by reading it we can do it. For example, for the tic-tac-toe game we could do it without developing a CRC card, but for more complex problems we need to develop the CRC card. The responsibility here are the methods that will be supported, and the collaborator is the class whose services will be invoked by this class. So, this is an example of a CRC card, name of the class, and then this is the method it needs to support, find book, and to be able to find book it needs to invoke the book class method. It needs to support a create book, and for creating a book it needs to invoke the book class method. Similarly, for reserve book it supports a reserve method, and then as part of the reserve method it invokes a method of the book class. But how does we go about developing the CRC cards? Once having the CRC card, identify a use case and then determine roughly how many classes would be required to collaborate for this use case, and then we get some team members, maybe 3 or 4. Each team member is distributed some of the cards, 2-3 cards, and then the use case text description is read out, and as the use case text description is read out, the team members identify if their class need to do anything. This is called as the structured walkthrough. As the use case scenario is read out, let us say a book to be issued to a member, then initially the member identifies the book, and then the members list of issued books are checked, and once it is read out that the members list of issued books are to be checked, then the team member holding the member CRC card for the member class will say that for checking if the books, how many books have been issued to the member class can check it, and then he writes the responsibility as check how many books issued, check number of books issued, and so on. As the text description is read out, each of the team member identifies if the class they are holding, the CRC card for the class they are holding, whether it needs to take some action, and that will appear as the responsibility. Now, once the sequence diagram is done, the class diagram is automatically developed if we are using a case tool. Otherwise, we need to check the sequence diagram, identify all the messages that are sent to this class and put them here. These are the responsibility of this class. For every class, if we go through the sequence diagram, we will see that these are the messages that are sent to this class, and we just list them out here as the methods to be supported, and based on the method to be supported we write the attributes, and that forms our class diagram. Now, let us take the next problem, which is the supermarket price scheme. We had also developed the use case diagram for this problem, but just to refresh your memory, I will just quickly read through the description of the problem, and since the use case diagram was already developed, we need to develop the domain model, and for that first we need to identify the entity class, and once we identify the entity classes, we can look at the use case diagram and easily identify the boundary and the controller classes. Now, please keep in mind that you will have to identify the entity classes, and with that perspective, while I read the problem, identify what can be the entity class. Supermarket needs to develop a software to encourage regular customers. So, if you are looking for entity class, the customer is a noun and there are many customers, and the supermarket needs to remember the residence address, telephone number and driving license of the customer. And from this description, we can identify that the customer is a entity class, and we need to aggregate the customer using a customer register. The customer register class will aggregate the customer class, and there will be many customer records that will be created, and the customer record here itself we can find that the attributes are residence address, telephone number and driving license. We can write the attributes if we can, and each customer is also assigned a customer number. So, customer number also becomes attribute. From this part of the description, we can identify customer as entity class. A customer can present the CN to the staff when he makes any purchase. The value of his purchase is credited against his CN. So, all his purchase needs to be remembered, and these will form the purchase records. And at the end of the year, the supermarket awards prize gift to 10 customers who make highest purchase. So, all the purchase has to be remembered, because at the end we need to look at the computer needs to look at the purchase records and identify the customer who has made the highest purchase. So, based on this description, we will write purchase register aggregates the purchase records. And so, two entity classes we have so far identified. It also awards a 22 carat gold coin to every customer whose purchase exceeds rupees 10,000. So, no entity classes here. The entries against the CN are reset on the last day of every year after prize winners list are generated. So, here also no entity classes. So, based on the noun analysis, we had identified two entity classes, and we can then look at the use case model and identify the boundary and controller classes, 3 controller classes and 4 boundary classes. Now, this is our domain model, the customer register and customer record. We have renamed the purchase record because these are actually the sales by the company, and the purchase is the from the customer perspective, and these are internal data. So, we keep it as sales record and sales history. So, these are the two important entity classes, and then we can identify and add the controller classes and the boundary classes, 3 controllers and 4 boundary classes. And then next we develop the sequence diagrams. First, for the select winner, this is possibly the simplest sequence diagram. We need to look at the sales history. First, the controller gets charged. The controller has the business logic, and it knows that the select winner can be obtained from the sales history. The sales history in terms computes the sales address, the total sales, and then reports to the controller. The controller finds the top winner details, asks it to find the top winner details, and then it for each winner detail identifies the address from the customer register, and then the controller asks the boundary to announce the winners. Similarly, register customer, once the register customer boundary, we have the register request coming, it is given to the controller. The controller first checks if it is already registered. For that, it requests the customer register to match. If there is a duplicate, it requests, it declines to register, it shows error, otherwise it generates a CN and requests the customer registers to create a customer record, and the customer record is created here, and then displays the CIN. Similarly, registered sales is reported to the controller. The controller requests the sales history to create a sales record. It creates and it is confirmed. So, we have so far looked at domain analysis and development of the sequence diagram for simple examples. We will not spend more time on the object oriented design part. We will now look at the testing part. Okay, this is also for the previous diagram. We have a small refinement here. The controller class actually has very little role here. It just gets the message and transmits it to sales history, and then it just gets confirmation here and transmits. So, the business logic here is very simple, and therefore, we can eliminate the controller class and we can redraw the small business logic and be part of the sales history. So, it is a very trivial business logic, and we have eliminated the controller class. Similarly, when the controller class has too much of business logic, we might split the controller into 2, and based on that we develop our full class diagram, where we write the methods based on looking at the sequence diagram. A case tool will automatically do it, and then we write any attributes that we identify. Now, let us look at software testing. Once we write the program, while testing it may fail. We may see a failure, a symptom of the failure. It says that fatal error, program will now terminate. But then we observe that the program has failed, but we do not see the bug. This is the symptom of the failure. By testing, we identify the failure, if there is a failure, but we do not really see the bug or the error which had caused the failure. For that, we need to do a debugging to identify the bug. So, it is important to see here that when we run test cases, we see the failure, we do not see the bug. A failure is a manifestation of a bug or a fault. There was a bug in the code, and while running, that manifested itself in the form of a failure. We don't see the bug, but we see the manifestation of it. But then we must also remember that even if there may be a bug, it may not lead to a failure. For example, the data that we give does not lead to the error to express itself. Let us now try to distinguish between error, fault and failure. Programming is effort intensive. We manually write the code and therefore inherently error prone. In 1993, the IEEE standard defined errors and faults as synonyms, but then a revision of that in 2010 introduced a distinction that errors and faults, there is a difference actually. Errors are the mistakes committed by the programmer, and faults are what happens due to that mistake. So, there is a bug or a defect. So, error and mistake are synonyms, and faults, bugs and defects are synonyms. We are almost at the end of the time here. We will stop at this point and continue on this topic in the next lecture. Thank you.